So differentiation from first principles. I think it's always good with these to write the answer down first. So let's just write the answer down and we'll see what within the question where it's coming from. Differentiate this, we're going to get 2 over 3 times x minus 1. So that's my answer. So if we say f of x is equal to 1 over third x squared minus x plus 3, we want f of x plus h, which is equal to 1 over 3 x plus h to be squared minus x plus h plus 3. So that's going to be a third by x squared plus 2xh. This is never going to change. You're always going to have x squared plus 2xh plus h squared minus x minus h plus 3, which is going to be equal to, we can write x squared over 3 or a third x squared plus 2xh over 3 plus h squared over 3 minus x minus h plus 3. And then just fill in f of x plus h twice. Now we want f of x plus h minus f of x. So x cubed, x squared, why do I write x cubed? X squared over 3 plus 2xh over 3 plus h squared over 3 minus x minus h plus 3. And then underneath we're going to write minus f of x, which is minus x squared over 3 plus x minus 3 to cancel off 3 of my terms. So f of x plus h minus f of x is equal to 2xh over 3 plus h squared over 3 minus h. Now have a look at our answer. 2x minus 1, 2x over 3 minus 1. You can see the 2x over 3 here. And how would I get a minus 1 into this? I'd have to divide by h. So if you can't remember, you should have practiced this loads of times, but we have to divide by h at this point. So dividing by h, each term divided by h, I'm going to get 2x over 3 minus 1 plus h over 3. So this is f of x plus h minus f of x over h. So now all I need to do is get the limit as h tends to 0 of f of x plus h minus f of x over h, and that's equal to, this is going to tend to 0, 2x over 3 minus 1. So if you haven't practiced differentiation from first principles, you are throwing away valuable marks. This was worth 20 marks out of 25 in 2017. Part B, this question was a composite function, and this is, you read this as f of g of x. So g of x has replaced x within f of x. So what we do is we put x plus 5 in for x. So my f of g of x, or my f of x, becomes the natural log of 3 by x plus 5 to be squared plus 2, which is the natural log of 3 times x squared plus 10x plus 25 plus 2. So it's going to give me, and the 2 is outside the bracket, just be careful, the natural log of 3x squared plus 30x plus 75 plus 2, 77, if we just jump a step on. So we want the derivative of f of g of x. So the derivative is equal to, well, ln x goes to 1 over x when it's just x. So it's going to be 1 over 3x squared plus 30x plus 77. But when it's not just x, we have to multiply by the derivative of the bracket. So we multiply by 6x plus 30. Differentiating 3x squared plus 30x, 30. So therefore, what I end up with is 6x plus 30 over 3x squared plus 30x plus 77, and I'm asked to find when x is equal to a quarter. So f of f prime 0.25 is going to be equal to, so just type this into a calculator. You could write it out like this if you wanted, but you don't need to. You could just write the answer because you're going to use calculator here. But it's just put 0.25 in for x. And we're asked for it correct to 3 decimal places. It's giving me 0.3719. So 0.372, correct to 3 dp.